Oh yeah, see right here is Gonzalez's hips. 1 hour and 33 minutes left. I printed that without supports though, so we'll hope for the best. But even without supports, it should come out better than a half a rib cage.
Are these strawberry pies hard to set up or not really?
No, not really. They run Linux. You have to SSH into them. So like this one I can get to by that IP address. That's where it's running on the network.
Okay.
So a Raspberry Pi is just like a computer that by default you would put Linux on. We're running a Linux with a certain software running on it called Repetier Server. This is for managing 3D printers. So we're running a piece of software. So we can think of it like a Windows machine or a Linux box or something like that. We just happen to be running some specialized software on it that allows us to do this stuff. Okay, so let's keep trucking here. All right, so we've kind of gone through like the backstory of data and interpreting data and this being a complicated thing and the idea that it doesn't necessarily matter if we have tons and tons and tons of data. There's a such thing as maybe too much data and maybe a final truth that we don't necessarily have to spend a lot of time talking about, but just kind of trust me, that's the truth. I think we've talked about enough things that this is going to be clear enough, is that I mentioned a little bit ago that data science is almost like a pseudoscience, where I think there is a such thing as being good at it. That being said, we're going to be looking at a series of tools in here that are going to help us look at different data. That doesn't necessarily mean we'll be able to draw good conclusions from that data, if that makes sense. I think we become better at asking the right questions. So what data science ultimately allows us to do, so let's just think about this in terms of our tools. So let's call this data science tools, allow us to conveniently query data such that we can spend our time determining which questions to, I'm going to put it in quotes here, ask rather than writing software that works with the data. Because asking might mean different things. We're going to deal a lot with data visualization, like looking at it, but that's going to be the result of like asking a question. So that's, I don't know, that's maybe not a great response. It's probably just as good as just saying I wanted to, I suppose. Needed to be capitalized, I suppose. All right, so this is kind of what's new for us in today's world, is that we have all these tools that automate a lot of this process so that as data scientists, we can spend our time saying, okay, here's the data that's in front of me. I wonder if there's a relationship between this and between this. I have a data set in here I will look at in a little bit. Maybe I decide to ask the question if there's a relationship between, I think I have breakfast cereals or something. There's a relationship between the price of breakfast cereals and the number of carbs in breakfast cereals or something like that. You know, you can sit here and dream up the questions because you're not spending your time writing the tool that's basically doing the dirty work of organizing and parsing the data into a usable format. Make sense? That would have been something we would have had to write a long time ago. And like last semester in 518, we wrote that for our CSV file of airport or flight information to get the direct flights from Milwaukee to other airports, that stuff. So we wrote our own custom tools where this guy will just do it for us. Okay, so data analytics versus big data. We've kind of already talked about this, but I want to talk about these three things here. So we've in a roundabout way talked about some of these slides. All right, so when I talk about big data, we're really talking about, or when we talk about big data, we're really talking about huge data sets, right? Data analytics is the idea of analyzing data and pulling meaning, telling a story, where big data is performing data analytics on huge amounts of data. Too much data for a human being. All right, so that's where computers come in. That's where computer science is involved in this guy. All right, so we have kind of three different broad approaches to data analytics. So we can either describe data. So this is looking at data from the perspective of what's happened in the past, right? So something's happened, we've collected a bunch of data on it, and now we want to have different ways of exploring that data to pull information about what's happened, to learn about the story. What story does the data tell, right? So that's descriptive data analytics. Let's just ask the question of what did happen. Predictive data analytics, which might be kind of, let's call this the hot topic, something like that, is predict future based on the data we have. So think about this like in terms of the stock market and things like that, right? Well, based on what's happened with the 4 zillion different variables that human beings couldn't keep track of, what will happen with Apple stock in the next 3 years? Again, we're trying to pull meaning out of data that might be meaningless to human beings, that might not even be meaningful data, right? Because we might overfit, we might draw bad conclusions from it, but effectively data analytics, the predictive data analytics would be how to write software that effectively becomes a fortune teller. Make sense? All right, but we already have that in our magic book. We don't need it. We don't need this crap. Okay, so him and I, we just pack it in. We got our magic book. We're fine. We're out of here. Okay. All right. So predictive. Now, prescriptive data analytics. This makes real-time decisions based on real-time data. All right. So this is what should I do right now. So this would be the type of thing that maybe Teslas use. Right? So Tesla cars that are making decisions, and this is kind of where we start getting crossover with like machine learning, right? Okay, so the idea is like, okay, my car's driving itself, it's on the interstate and things like that. And one of the things you maybe heard the Tesla folks talk about before is it gets smarter over time. Because every single Tesla car that's on the road is collecting data and sharing that data with the Tesla network. Right? So this is more and more information about how people are behaving on the roads and that kind of stuff. Go ahead.
When you fed your brain, the brain that you guys created with data, the first time you got 98% right away, right?
Yeah, after it was trained.
Okay.
Yeah, I trained it on the 1 through 5 table,
yes,
and that took a while.
Then
I showed it data it had never seen before. And it got like 98% right.
Then did you run again to see if you would get 100% right or no?
He would only get more right if we had trained it more on that data. So what we were really proving is the idea that we taught him the pattern of multiplication because we taught him with the 1 through 5s table and tested him on the 6 through 10s table. Data he had never seen before. And of course, my neural network was male. Since I keep calling it him. Yeah.
Okay.
All right. In college, and I remember that you figured this out. Or you
figured what out?
The multiplication table thing.
Oh, the neural network thing? I did that when I was 9.
Yeah.
No, I did. I was older than that. It was a college class. It was artificial intelligence undergrad class.
All the way back in those days.
Oh, yeah. We called it data mining. All right, so prescriptive would be making decisions right now based on an accumulation of data that might be still feeding in, something like that. All right, so this is kind of common knowledge. I don't necessarily care if you memorize these specific words. Oh, I don't know. I don't necessarily personally care, but it's probably fairly important to at least know the ideas, right? What happened in the past? What will happen in the future? What should I do right now? Okay. All right. So we talk about the different kinds of variables that might be part of our data. So we have some things that are numbers, okay, and numbers come in a couple of different formats. We have continuous numbers, so these would be like floating point numbers, like 3.14. So how many numbers are there between 3.14 and 4?
Infinite.
An infinite number of numbers, right? Okay, so that's why we call them continuous numbers. Where if we have discrete numbers like integers, we can say how many numbers are there between 6 and 10, assuming we're saying that there are discrete values. We have 7 and 8 and 9, right? So we have 3 numbers in between them, or you can say 4 if you want to include the 10, whatever. Okay, so 2 different kinds of number types. These are quantitative things. That makes sense. Quantities of things, right? Then we have categorical or qualitative things. These are labels or strings based on a category or a quality. All right, and then within that, within categorical terms, we have nominal and ordinal. So nominal means they're not necessarily in any order, where ordinal means they are in order. So an example would be like red, yellow, green could be labels. Those would be categories of things. And there isn't, red coming before green isn't meaningful, right? So those would be nominal values, nominal categories. Whereas ordinal, if we talk about like letter grades, A, B, C, D, F, how come there isn't an E?
I don't know.
F just represents fail.
Yeah.
It's just the first one.
But the other ones don't stand for anything.
Yeah.
Well, A stands for awesome. Ace or awesome. B stands for bad. C stands for crap. D stands for dumb. F stands for fail. E just stands for eh. Eh? All right, so those are the kinds of variables that we might be dealing with our data. All right, so data visualization. This is kind of the whole core of what our first chapter, I'm going to just call it chapter 1. I know it's chapter 10 or 9 or something like that in our book. Yeah, in our book, but it's chapter 1 of data science. All right, so the first part of the data science portion of the book dealt with data visualization. Now, when I say data visualization, what we're really talking about is seeing a picture of our data. Because pictures, we've heard the phrase before, what is it? A picture is worth 1,000 words or something like that. All right, so a lot of times seeing a picture of your data allows a human being to immediately find that story, get that semantics out of the data. So most of what this first chapter talked about is the various ways we can visualize data and which of those ways is kind of most appropriate for different kinds of data, the nature of data. Now, realistically, this is something that you end up getting better at over time. This kind of goes back to what I was saying before, that you can have a competency in how to perform data analytics, how to be a data scientist. But there's a such thing as a bad data scientist and a good data scientist who both are equally competent at using the tools of the trade, let's say. But a good data scientist, through their experience or their own intuition or something like that, might ask the better questions. They might work with cleaner data sets. They might throw out outliers that they're not necessarily, they don't want to screw their, skew. Well, skew. Okay, I think they kind of mean the same thing. They don't want to skew their data. There's a certain amount of talent or that experience can grow into the situation, right? All right, so data visualization is the idea of looking at charts and stuff like that to get information about our data. All right, so cardinality, this is only important when we talk about converting charts into a couple different things. This is the number of unique elements in a data set. How many different things are we dealing with? So high cardinality would be like student IDs. So, if we think about the student IDs at Concordia, our foo numbers, how many foo numbers have existed over the life of Concordia, I guess, since we probably instituted the foo number, probably when Concordia opened its doors, it wasn't called a foo number. It was probably something else, but we'll just round down and call it a lot. Okay, a lot of unique student IDs. So that's a high cardinality in that data set. So we would probably not want to gather a lot of information from just thinking about data sets in general off of a student ID. We'd want more information than that. We'd probably want to know about like kind of year in school, stuff like that, to find out if there were certain patterns that occurred, you know, in the 90s or in the 2000s or in 2014 specifically, you know, that kind of thing, as opposed to patterns across all student IDs of all time, which might also be interesting. But at that point, you're dealing with a lot more data. All right, but general cheat sheet here is high cardinality, lots of unique stuff. Pie charts and bar charts lend themselves to those kind of things. Low cardinality, so like student ages. So in college, we don't have a whole lot of unique ages, right? You can close your eyes and walk into the cafeteria and point at somebody and guess an age between, 19 and 24 and have a pretty high accuracy of, because that's kind of your typical age for college folks. You got your outliers, but that's going to be low cardinality. All right, so these work for scatter graphs, line charts, and histograms. And we're going to talk about these kind of at the high level. I'm not a designer-y type of person, so I'm going to focus a lot more on kind of the technologies and the code and things like that behind it. And I'm certainly not a data science expert. Okay, so several of you, I think you do it at work, right? So you're going to very likely be more talented at data science decisions than I would be. But I can look at stuff through the Python window and the coding stuff and how do you accomplish, ask the right questions in the right way type of perspective. Okay? Don't die. All right. So Python for data visualization. So Python is the core programming language we're going to be using. It's probably become, I think it's fair to say it's become the go-to move for data science now. For a long time, languages like R were pretty popular. R was based on Java syntax. And it's not that R is not popular. I think it's probably somewhat unfair to R, but it feels to me like R has kind of become the COBOL of data science, where it's been around long enough now, and it was the go-to move for data science for a long time. And Python has become so popular as a language that there was a high demand for libraries to come into existence for performing data science with Python, that it's kind of taken over almost out of, not necessarily because it's the better tool, because I don't think there's really many people arguing that there's something wrong with R. I think it has more to do with the maybe the support, flexibility, and community size for Python. But in any case, we're looking at data science through the eyes of Python. So keep in mind that Python is our core language we're going to be using in here. Now, we're not using standard out-of-the-box Python. We're using a whole bunch of extra libraries that have data science-y stuff built into it. Okay? So here's some of the things we use. So one's called NumPy. NumPy is pretty common even outside of data science stuff. This is effectively a library for Python that does a whole bunch of mathy stuff. All right, so mathematical functions required by other libraries. So NumPy is a pretty common thing that we might need. SciPy, statistical functions. Pandas, this is our DataFrame statistical function. So this, we would probably call pandas here our data science package. That's the guy that's actually allowing us to manipulate and work with our data. All right, and then we have this generic package called matplotlib, which is for generic data visualization. And it can be used, and is used, in conjunction with pandas for visualizing our data. And we'll look at some of this. All right, Scikit, which they don't use in the first section, but this is a machine learning type tool. Now, Seaborn, this is kind of, it's built in terms of Matplotlib. All right, so it's another data visualization tool, but it's not its own separate thing. You need Matplotlib in order for Seaborn to work. So what Seaborn does is it says if you have a data set that is compatible, or yeah, let's just say compatible to keep it simple, with Seaborn, Seaborn might let you work with that data a little bit more conveniently than Matplotlib would directly. Seaborn also has a whole bunch of data sets built into it. Like the one the book used quite a bit was like a Titanic data set, right? Okay, and then Quandl. So this is for taking our data and analyzing it, pulling some information that isn't necessarily related to visualization of it. All right, so these are Python packages. So let's talk about, let me just see here. Okay, yeah. So let's talk about Python here for a second. Now, if you want to get Python on your computer, if you notice that in the book, you can click a link and it says, go and run this code, and it takes you to like a website that can run the code and, inside, which is fine. If you want to do that, that's fine. I would recommend going to python.org, downloading Python. Now 3 point something, 3.8.0 is the newest version on here. Yeah, anything 3 is fine. Let's just say. So there's kind of 2 stable versions of Python. There's a Python 2.7 and then a Python 3. And they are not necessarily compatible with each other. So really Python 3 seems obvious, is the newer version of Python. We might say, well, why isn't that just Python? Well, there's so much stuff written in Python 2.7 that they needed to keep supporting the older version of Python. They are actually finally getting rid of it now. So if you're not on Python 3, you need to be on Python 3 from a website development type thing. We're going to be using Python 3 in here. Now, one thing I'll point out that will be helpful to several of you, especially on the Windows side of things, is if you go and download Python, you want to get the 32-bit version of it. There are some compatibility issues with one of the packages. I don't remember which package it is. Okay. Well, use at your own risk. I don't remember what the complication was.
No, yeah, I got the 32. I read that.
Yeah. No, but I didn't just read it. I've experienced it at some point a year or two ago, specifically on the Windows side. So if you got the 64-bit version and it's working fine, that's fine. But I would encourage you to get the 32-bit version just to make your life easier. So that would be Python 3.7.5. You're going to want this guy right here. Copy link address.
Can I just download the new version?
Yeah, probably. All right, so you're going to want the x86 installer, either one, the executable or the web-based one. Don't get the x86 64 one. Yeah, and it's entirely possible that maybe the problem I'm referring to has been fixed in one of the packages or a newer version. So use at your own risk, whatever, but you're not going to hurt anything by going the 32-bit version route. We're not.
Wait, how do you specify to do 32?
I'm showing you right here on the screen.
No, it's not.
Yeah, for
Wait,
For
so
iOS.
how did you
I went to downloads, and then I said view full list of downloads.
And you did.
So under
That's not
if you
what I
went 3.8, well, it should be.
Oh, okay. Scroll down more. Maybe. That still does not look the same.
Well, whatever. Find something that looks like this, x86 that doesn't have a -64 on it. That's what you want to download.
Did you
Yeah.
download the 3.8?
I'm running it on my Mac. I have 3 point something on here. I don't know what I have.
Downloading the 3.8.
I have 3.6.4. So, yeah. So I'm running 3.6.4 on my Mac, but I have Python 3 and Python 2 installed. If you have a Mac, you actually already have Python installed, but you have Python 2.7 installed.
Yeah, exactly.
So you do need to install Python 3. But so notice here that my Python 3 is called Python 3, where I also have a Python. My normal Python, if I do Python -- version, this is my Python 2.7. So when I installed Python 3, I made it called Python 3. So I could differentiate between the two. Question.
Embedded zip file, execute.
Doesn't matter. I already said it didn't matter which one of those.
You said not one with the 64.
Yep, and I also said the other one. You're not fully listening.
That's because I was on the wrong, like.
So it was on the wrong page 5 times. Patterns.
Oh, which one? It doesn't matter.
It doesn't matter.
Wait, why are they all the same? That doesn't make sense.
Do the web installer. You'll be happy. Just do it. Do the web installer because it has nice next buttons for you. It'll make your life easier.
Install launcher. Do I want to add it to tab?
Yes.
You have to, otherwise it will be really
All right.
hard to change.
All right. So you'll need Python 3. Get it on your machine one way or another. There's plenty of tutorials out there. Blah blah blah. Whatever. How you use it with Windows is different than how you use it with the Mac, because I'll always go out to the terminal here. There's websites out there that you can do this with as well. If you click on one of the things in your book, here, is this one of them that, let me find one of them that says run this code. Here, run example. Yeah, so this takes me to a website called trinket.io/Python3. So you can do all your stuff in there as of right now as well. So basically no excuse for not being able to do homework and stuff at this point. I would encourage you to get an environment set up on your machine and get good at using it, because that's something a computer scientist should be able to do. All right, so debug it, get it working. You should be able to run these examples on here. But we should be seeing here, so in your Python, what are we doing? We are importing some stuff. So I'm importing a package called pandas. I'm importing a package called matplotlib. I'm importing a package called seaborn. Now, notice this thing where it says as PD, as PLT, as SNS. If we go back into, I pulled this right out of the book. Notice here next to it, it has alias. These are common naming convention aliases. Right? Nothing is preventing me from coming in here and saying, get pandas as LOL. And then any time that I would have said PD, where's my PD? Well, that's funny. I actually never use PD in here. Yeah. Right.
He's using PLT.
Okay, nothing keeps me from doing that. This is just giving me an alias, a shorthand, so I don't have to type in matplotlib.pyplot. Make sense?
Oh, 9.5.
All right. So pick your poison how you want to run it, but this is Python interpreter here online. I got to this just from the book by going to one of these images that had some code above it and just click run example, and it just took me to the website. Okay, but you can run the same example on your computer doing that.
Should work too?
If you have everything installed correctly, it should. Here, let's find out. Because I don't know if I have everything installed correctly. But we should probably just assume I do. So if I do that, and then I need to open up, I'll open up Atom. Man, I can't see anything again. Ninja. Okay, I'm going to leave that one open because I'm going to show you that in a little bit. New file.
Where are you right now?
I'm in a text editor called Atom.
A text editor.
Yeah, you can use Notepad, whatever. I just am using Atom. Some people use Sublime. So the one I use is from atom.io. That guy.
Okay, that's really easy.
It's a text editor. You can use whatever you want. All we're using this for is typing in Python code. We're going to run stuff from the Python command line for testing it. All right, so pick your favorite text editor. What's nice about Atom and other text editors, so notice here I just pasted some stuff in. It doesn't have it color coded or anything. I'm going to go ahead and save this. I'm going to put it in my home directory. We're going to call this guy
LL.
Because I was trying to run straight from the shell.
Yeah, I'm going to run it from the shell. I'm just
That's
typing
what-
stuff here.
Okay.
I'm just typing stuff here.
I was typing everything on a shell.
I actually prefer that. We could do that.
Oh, really?
Yeah,
Okay.
so here, we'll do that.
That's
So I'll come out here, and
Python 3.
so if I do test.py, there's my code here. So if I want to, I can type stuff in there. So this
Did you
is,
say you actually prefer that?
if I'm writing code short like this, probably. I mean, Atom does some nice color coding and indenting and crap like that. So maybe anymore, I prefer to do it inside of Atom. But if I'm just doing a quick little change, I mean, years ago, your whole screen was just the terminal. You didn't have a graphic user interface or anything like that.
Which section did you get the code from? 9.
Yeah, I mean, I guess 9.5. Is that what it was? It doesn't necessarily matter. 9.5 bar charts. 9.51. All right, so there's my code. We've typed it all in. We're going to say it's good to go. What's this guy doing? Well, I'm importing pandas, matplotlib, and actually let me just show it to you in here because it's more. Is this easier to read or was the other one easier to read? Okay, so I'm importing all my stuff up here, right? So here's my data science thing, which Seaborn does use. Seaborn's using the load data set, so Seaborn relies on pandas and also relies on matplotlib. All right, so I'm getting pandas, matplotlib, and Seaborn. I'm going to use Seaborn to load a data set called Titanic. That's something that comes with Seaborn. This isn't something I downloaded or something like that. It's one of the test data sets for Seaborn to learn this stuff. The book uses it pretty heavily. All right, so this is going to give me my data set, and we'll talk about what the format of that is here in a few minutes. But, I get my data set somehow, right? And it's going to put it inside this object here called Titanic. Then I'm setting some style, what it looks like, some stuff like that in the set style, so forget about that. You can even leave this line out. It'll just be an uglier bar chart. I'm setting the title. Also, make this whatever you want. So this is passengers by class with font size 20. This all reads pretty. So remember a little bit ago I said something about Seaborn makes it kind of extra convenient if you have data that's compatible with Seaborn. It makes it extra convenient to visualize that data. So what am I doing here? I'm saying read my data set the style, set the title. Now here's the count plot. So X is going to be the class. That is the class Titanic, big cruise ship, right? And you had first class, second class, third class passengers. So that's the class they're talking about that. And then what color is that? And then the data it's coming from is the Titanic data set, which is this object up here. And then we're ultimately going to save this in this thing called vertical bar chart PNG. So this will save it in the same directory as we're currently sitting in. All right, so I'll go ahead and, that's an Atom. So I'll come back here and I will do Python 3 test.py, and I'll go ahead and run that. And it's going to do its thing for a second, and there is my chart.
That's awesome. I could not make that happen.
You can go ahead.
Now, one thing to see here, so I'm gonna close this. Sorry. Oh, do I actually have to kill off this guy?
You interrupt now. You take a little time.
Python 3 is not recognized.
Well, that's because I have Python 3 on my computer. You probably have Python on your computer. So get Python on your computer. You probably have Python 3, but I have 2 versions of Python on my machine. Remember me talking about that? You don't remember that either.
Called Python.
All right, so if you have that issue, so she has an issue called no module named NumPy. What you would do is out here at the command line. Now, I always put a 3 at the end of mine because I have 2 versions of Python installed on my machine. You very likely, unless you're on a Mac, have 1 version of Python on your computer. Okay, so more than likely, when I type in Python 3, you just type in Python. When I type in pip3, you type in pip. Okay, so pip is my package installer, so you can say pip3 or pip install NumPy. And mine says already satisfied, yours is probably cooking, doing some stuff. All right, so whenever you try to import a library that says not found or something like that, do a pip install that, and it'll install it on your machine in your Python library thingy majiggy. Okay, so notice here that we have this thing called vertical bar chart.png, and it actually saved that. So it did launch it on its own, but if I go into my here's this image that just got created. So it saved it on my computer too. It did pop it up automatically, because that's what the Python interpreter thing did, but it saves this image so I can use it later or whatever. So if we look at the Titanic passengers by class, we see that there was almost 500 third class passengers, there was less than 200 second class passengers, and that there was over 200 first class passengers. This is a good way of visualizing this data about Titanic, where if I were to look at this entire document of data, it would have been very hard for me to get this information, have this story told to me this quickly, right? So power of data visualization. All right, questions on that? Okie dokie.
You guys work? I didn't have to install everything, so we're still working on that.
I don't have a module called nothing.
So that's when you have to do the
Pip install NumPy.
I
PIP space install space NumPy. If you're on a Mac, one thing you might have to do sometimes is you might have to do sudo. If you ever get an error that says, you know, permission denied or something like that, it might be that that particular package is having to overwrite some or change some files in a secure directory. So you put sudo before it. Sudo says do this as administrator.
I had to do that for the C programming stuff.
Yeah. So this says do this as administrator. Pretend like you're administrator. It's the equivalent of on a Windows machine where you can right click and say run as admin. It's the same thing. Because really this is shorthand for typing SU and pressing enter, and that'll ask you what your root password is. But Mac doesn't let you take over a root password. It just, well, sudo works on a Mac. Sudo lets you do something as admin, but the person that's logged in, if they're already admin, they are considered the root password, the root user. I think there is a root password, but that's not who I'm logged in as. I'm logged in as an administrator on my, yeah. So SU is how you become super user. That's what SU stands for. SUDO says do as super user. That's what that guy means. Old Unix stuff.
Do you have to use the abbreviations when you install?
Which abbreviations? These guys?
Yeah.
No. Because these guys you can call whatever you want. All right, so keep trucking here. We have a new data structure showing up to us. Whether you've had Python or not, doesn't matter. Remember, Languages are all the same. Remember stuff, asking questions, repetition. We learned Scheme in 15 seconds early on this semester. We worked with a couple of different languages, doesn't matter. So in Python is a loosely typed, so if we just pigeonhole Python real quick. Who is Python? So Python is a high-level, loosely typed, object-oriented, general purpose, interpreted programming language. That tells us a lot of information. The fact that it's a programming language tells us what? That it has facilities for remembering stuff, asking questions, and repetition, right? It's a programming language that has all those facilities. All programming languages do. The fact that it's high level tells us that we're not writing in zeros and ones, and it says we're not writing in MIPS. We're writing with the power tool, right? We're writing a high level thing, so one-to-many relationship. We write one line of code, it translates into a whole lot of lines of low-level code, which translates into equivalent number of lines of machine language. Okay, loosely typed. Loosely typed says when you're creating variables, you don't have to define what kinds of values they're meant to hold. All right, so languages like Java, if I want to hold an integer, I have to say int a equals 5. In Python, I just say a equals 5. All right, Python doesn't make me define the kind of value I'm going to hold. Now, with that, though, comes a performance hit. Since I don't have to define the kind of value I'm going to hold, during runtime, Python has to figure out what kind of value is inside of a bucket before it'll let you do something with it. It uses something called the type inference engine. All right, not really important for this class, but this tells us a story, right? So we're performing data analysis on the Python language here. High level means it's one of our power tools. Humans like this. Loosely typed says when I create my variables, I don't have to put a type before it. Object-oriented says, oh, I can deal with objects in this guy. I don't have to write all my stuff procedurally. So this guy is like Java, like C#, like C++, like Swift. It's like those kind of languages. General purpose means it can solve all sorts of computer programming problems. It's not specific to a very specific problem. Again, it's like Java, like C#, like blah, 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 blah. All the general purpose languages. Interpreted, so this is where it differentiates itself, sort of. So Java.NET, like C#, for example, C, C++, these guys are compiled languages. We run it through the compiler. We all know what a compiler is, right? We've recently written a crappy one. All right, so we run those through a compiler. It translates it into the low-level code, which then runs directly on the CPU. An interpreted language runs during runtime by the interpreter. So it's actually going through a translator at runtime rather than compiling it before runtime. What does that ultimately mean? Well, it just means that the tool we're using is probably a slower tool than a compiled language. And when we saw that this guy was loosely typed, we could have made a pretty good guess that this guy was also interpreted. Interpreted languages tend to be loosely typed. Compiled languages tend to be strongly typed. C#, you put int a equals 5. C++, int a equals 5. C, int a equals 5. Java, int a equals 5. Swift, var a equals 5 as int. A little bit different.
But C# we can also using by equals to,
Yeah.
but it will actually include code.
Yeah, at runtime. Yeah, it locks it in at runtime. All right, so we know it's an interpreted language. Make sense? So these data points here, we've just done data analysis on the tool that is Python that we're going to be using. And as a computer scientist, this tells us a whole lot of information about this tool. It tells us likely how we're going to be creating variables. It tells us the fact that variables exist. It tells us the fact that conditionals exist. It tells us the fact that loops exist. Make sense? All right. Now, when we see that it's interpreted and we start saying, oh, then what does that mean? Python must be like other interpreted languages. Other interpreted languages are like PHP, Ruby, Perl, JavaScript. Okay? Questions on that? So again, this class isn't about Python. I'm not going to test you over Python backstory stuff. I'll test you over potentially Python code that's related to data science. But it's not about Python, but as computer scientists, we're using a tool called Python. I could have used a tool in here if we happen to have data science packages for it called Bob's New Language invented yesterday. All hyphenated probably. And as long as you know how to define variables, ask questions, and repetition, you can use that language. All right? Super, super, super important skill set for all computer scientists to have is to not view languages as hurdles. It's just a programming language. It's a way for us to talk to the computer, and it's a power tool that is meant to make us happy. We've already seen we don't like the zeros and ones, and I've gotten the impression you guys weren't huge fans of MIPS. So we don't want that low-level language. We don't want that zeros and ones language. These languages are for us. Doesn't matter what you call them. They're all the same. All right? So now what you would say, every language has their little nuance. How many of you in here have never done or haven't done much with Python? Touched Python at all? Okay. So if I were to give you one important nuance of Python, and this is actually why Python is the language we use as our very first programming language in our program here now, Python absolutely requires indentation. So in most modern languages, C-based languages, you have those opening and closing curly braces, and you're kind of encouraged to indent inside the curly braces. Python doesn't have curly braces, and you're more than encouraged to indent. You have to indent, otherwise it does not belong to that block. You'll see this through some examples, but if Python had a character trait, it would be you must indent. Right? That's Python's thing. Now, as an educator who teaches programming a little bit, I think it's a great first language because one of the things that's always difficult to get beginning programmers to do is to format their code in some sort of reasonable format. Python does it for me. They say, look, if you don't format your code in a reasonable format, I won't work. All right, so Python does this for you. All right. So Python has all your normal suspects, variables, ints, chars, blah, blah, blah. It has things called lists, which are kind of like arrays in other languages with these square brackets. But then we have this new thing. Now, you may have heard of this before. It's not a brand new thing. It's not even something that's married to Python, but it's something that is maybe not super commonly used in programming languages, even though most languages will have one of these guys. It's something called a tuple. Think of a tuple as an array that you cannot change. Okay, and the fancy word for that is something called immutable. A tuple is immutable, which is a crazy way of saying you can't change it. It's read-only. Once you set the tuple, it's done. That's the value. Make sense? Don't have to think about it any more than that for right now. Just if somebody points at something and says, that's a tuple, this tells you what that means. You're going to see it inside parentheses, and that's what it's always going to look like. It can't change. Cool?
There's a question.
We will use it.
For tuple, I think not like array, because tuple technically you can have a different data type there.
You can have a different data type in arrays as well.
Well, in Python, but you can. But
Any language. If it's objects, you can have, as long as it comes from an object.
But if you say it's an integer array,
Yeah.
then you cannot having float there.
Depends. Is it a integer, capital I, integer object array?
Let's say if that's for Java.
Oh, okay. Well, no, actually, let me go the other way. If you specify something as an integer array, you're right. You can't put other things in there. But if you specify something as an object array, you can put integers and floats, and you can put anything that is an object, including all of those things. So remember, Python is loosely typed. We don't have types in front of it. So we can create the identical thing in languages like Java.
When I was programming C# I using tuple quite constantly because you can define return object as a tuple. So
Yep.
you can say I can return both integer, float, anything I want.
Right. It allowed you to have functions that return more than one value,
Yeah.
instead of having to create an object to package your collection of values you were returning. Yeah. But once you returned it, those values were read-only.
Yeah.
But you still had your data. You could put them in changeable variables and move on with life.
Mm-hmm.
Right. Okay. But point is that, well, you just said it yourself. Tuples do exist in C#. They exist in other languages.
Yeah.
And what I'm telling you is that the character trait of a tuple is that it can't be changed. We can think of it as a collection of information. You said, I want to return 2 things, you can return 2 things. You want to return 8 things, you can return 8 things. Okay? Tuple says you can't change those things. Those things, as you said, in tuples, they don't have to be the same. You can return an int and you can return a string, right? You could do the same thing with an array as long as you set it up as an array of generic objects. So you could pull it off with arrays as well. So I don't know if that's a differentiating term so much as it is that tuples are read-only. So you could think of a tuple as a read-only array.
Probably you can say it's a SAM in this way.
Yeah. All right, so but kind of an important, let's call it computer science-y vocab word here that you might see is when you see mutable or immutable, that's usually going to come in a book somewhere or some person who's trying to act smart. Where you're going to say, well, you want to use an immutable collection. I've heard people say this stuff. All right. No, I don't use big fancy words. I teach you how big fancy words mean so you can deal with idiots. Right? Because typically people that use the big fancy words are the idiots. They use the fancy words to hide it. Right? So, yeah, immutable means can't change it. Mutable means can change it. So arrays are mutable. Tuples are immutable. And you go back to an old language like Objective-C. Objective-C had immutable and mutable arrays. You could have an NS mutable array and an NS immutable array. So an NS immutable array was a tuple. An NS mutable array was an array, a traditional array. All right, everybody get what tuples are? So when we use them later on, we got it? All right, so we have our objects. If we go back to our code here, where's my code? This Titanic dude here, after my load data set where I pass it something, this could be whatever my data set is, comma separated values. This happened to be something built into Seaborn. Doesn't matter. It's going to do its magic stuff, all right? And ultimately, it's going to pump out something into this variable here. The thing that's in that variable is one of these guys, something called the data frame. So a data frame is an object. Okay? It's a data structure, specifically for holding data. It's kind of a fancy way of saying an Excel document. It's a spreadsheet. Okay? It's a 2-dimensional array of rows and columns, where each row is an entry in your data set, and each column is going to be a variable associated with that entry. A value. Could be a numerical value, could be categorized value.
Why is the not just call it just a table?
Well, because they don't want to call it table. Pandas calls it data frame. So the table was already taken. I asked, why did they just call it Woot? That's what I would have named it. Mr. Gonzalez would have named it something I couldn't put on slides. So it's a whole different problem. Okay, but they call it a data frame. Okay, it's a frame for holding my data. All right, so this guy's just a fancy name for an object that effectively is a 2-dimensional array of stuff like an Excel spreadsheet. So we have our rows, which are indexes. These are individual pieces of data records, if you will. And then we have our columns, which are our values. These are stored as another kind of object called a series. So a series, basically a list. All right. And then here's some attributes associated with DataFrame. So we have the axes, the index of columns and labels, or the rows and column labels. This tells you, what's in here. This gives you a snapshot of what the guy looks like. Okay, so here's how many things I have. Those are my indexes. And then here's the pieces of information I have about those things. Those are my column labels. If I want just columns, this is going to give me my column labels. Columns will tell me the kind of information I have. So for instance, if I come in here and I say print Titanic dot columns, and I'll just go ahead and comment out the rest of this stuff. All right, so I'm not going to do any printing or anything. I'm just going to get my data set, and I'm going to print the columns from that data set.
Kind of cool how much information you can get.
Right there. So I'm keeping track of who survived, P class. I don't know what the difference between P class and class is. Sex, age, CSC548, Parch, fair, embarked, class, who, adult male, deck, embarked towns, where they got on, whether they're alive or not, and whether they were on board alone, I suppose. A couple of those seem kind of not sure what they mean. We maybe have to look at some of the data to get an idea what that means. Make sense? But at the very least, that's a way of us grabbing some data and then immediately dumping out to the screen the column headers. Otherwise, if I had a CSV file, I could have opened it in Excel, scrolled through, seen all my column headers, or I could have just written 2 lines of code here and used pandas to read a CSV file and then print out the columns. And that's equivalent to me opening up Excel and scrolling over the 4,000 rows or 4,000 columns to see all the pieces of information we're keeping track of. So we have D types. So this is the data type of each value in each column. So this tells me the kind of values I have. So if I show you that, this should tell me whether I'm dealing with strings or if I'm dealing with number types. So notice here we have survived. This is probably a label, like true or false. Oh, no, survived is actually a int 64, so it must be a 0 or 1, I'm guessing, for survived. So sex is an object, so that's probably a string. Age is why is age a float? Who knows? That's the type.
Maybe it is a year.
17 and a half.
Maybe this is like a year, so it's like a time span, so it will be float.
How come older folks never give you like a, well, actually there's a point. They never give you an age as a half. Like you go up to a 6-year-old, you say, how old are you? They're like, oh, I'm 6.5. Right? That's like a big deal.
When you're a kid, yeah.
Yeah. Why did years take so long when you were a kid? They seem to last forever. But now,
Years, like I've been at KD for 6 months now. Like,
it's just flying by, right? But like you're in middle age, you do the whole half thing. But once you get old, you do that again. You know, every extra day counts. You start giving fractions. All right, so we have our index labels. So let's see what that gives me for this guy. Just index, yeah, index. Yeah, so I have 891, 892 total rows. That must have been the people on the ship. 892 people, or at least people that kept track of here, right? My guess is this is probably going to give me the same thing as shape. So we also have shape order pair that gives the number of rows and columns. Actually, shape gives me something a little different. Well, shape tells me how many things I have and how much information I have about each thing. So 891 is the number of things I have, and I have 15 data points for each thing. Then size, number of values in the data frame. We already know what that is. No, actually, it'll be 892 times. I think size gives me the total number of values in there. Times 15.
Yeah, times 15.
I believe. I'm going to call it 91.25%. Yeah, 100%. We're at 100%. So I had the Brazilian grandma come and sniff the dirt. We're at the 13,365 actual pieces of data. All right, so then values will actually show me the values. This guy will get a little bit more sketch, right? So we're going to have somewhat of a screen dump here. Oh, interesting. It shorthanded it for me. But this is actually helpful. Well, it's not actually all that helpful because it cuts off a bunch of stuff. This would have been helpful for me to see the kind of values that each thing was. You know, so this is kind of the town they got on from. Was this the liver died thing? Well, whatever. This is what that function gives you. All right, so those are our data frames. Now we also have describe, head, tail. So head gives you like the first 5 rows. So that's actually kind of handy. So if I say head, and this is actually a function, not an attribute. Here's the actual information for the first 5. So survived is survived is 0, 0 or 1, like this. P class, that must be the class. So 1, 2, or 3, I'm guessing.
Yeah.
Male or female. Yeah, they do have age as a float, but I only see.
Why is it float?
Yeah. I have no idea what the SIB-SP thing is yet, but whatever. This is one thing you'll have to take into account sometimes. See this NaN thing? That stands for not a number. So sometimes you'll have something that's in here that doesn't have a number associated with it, and you have to deal with that. What's this? Yeah, right. Or is it Nana for grandma sniffing the dirt? Haha, Nan. On?
So why is it not a number?
Because whatever the data they tried to put in here wasn't something that was calculable. Basically, let's call it bad value.
Okay.
Not a number means bad value. That means it could be problematic if we start trying to do charts and stuff with it. It's going to be real hard sometimes to plot something that's not actually a number. All right, so this is kind of talking about the stuff that's in a thing. We have this function called loc versus iloc. So loc takes a range of rows and lists of columns to return as a data frame. All right, so I can say I want to get rows 2 through 20, and I specifically want to get columns age and sex. Loc lets me do that. iloc says I want the rows 2 through 20, and I want columns 4 through 6. So iloc lets me choose columns based on a range, where loc lets me choose columns based on a list of names of the columns. Okay? So we'll see those in examples, but that's just kind of what's in there. All right. Different forms of a data frame, and some of these things are actually easier to see in our in the book. Let me actually get to that here. Because you can convert data frames from a couple of different forms. Let's just get a picture here.
there.
What's next? Yeah, reshaping data. All right, so we pivot from going from long to wide. So notice here that in this chart here, Michael is here 2 times, for example, right? And what's that? Arushi? Arushi's there twice, and Roberta is there twice. So we have multiple data points for the same person, correct? For different dates. Well, here we have each person in here 1 time, and for each of them we show their 2 data points. So it's a different way of visualizing the same data inside of a data frame. So this isn't visualization at the graph level. This is visualization in how the data frame is organized. So this data frame has indexes 0 through 5, where the data stored in those indexes is date, student, and score. Where this guy has indexes on date. Instead of generic 0 through 5, we have dates that uniquely identify an index, and the data values are under the people's name. The column headers are the names of the people. All right, so that's long form versus wide form. Long form was this dude, wide form is this dude. And we could pivot from long form to wide form, and we can melt from wide form to long form. Pivot and melt. All right, so most of these are going to be fairly self-explanatory. We have bar charts. Here's an example of a bar chart. This is a relative frequency bar chart. So, I kind of tried to put in the slides here a breakdown of what the different charts are and the different kind of forms of them. So a bar chart depicts data values of category variables. They come in 2 different generic forms, vertical and horizontal. So vertical has the categories along the x-axis, values along the y, where horizontal categories along the y, values along the x. One of these might make more sense than the other, depending on if your category names are really long. Having them along the X might start getting crowded, or maybe having them on the Y will look cleaner. You'll be able to read the category names or something. So whether you do a vertical or horizontal bar chart might really be the decision between category length, name length. All right, so we have relative frequency bar chart. Instead of specific data values for each category, categories are shown as relative frequencies of the data values. All right, so we don't actually show categories over here. So this is professional European soccer player birth months, which is actually interesting. You remember me saying something in class about the NHL Canada? The number of players in Canada, number of players in NHL from Canada who were born in the first 3 months of the year. This is a pretty similar type thing dealing with professional European soccer players. They tend to be born early in the year. I'm guessing it's related to the age cutoff. Yep. All right. So actually, if we just look at that, so we see that 17%-ish of the professional European soccer players were born in January, where only like 2% were born in December. That's 1 month apart. You had a pretty significant difference in whether you're playing pro soccer or not. All right, then we have this thing called a grouped bar chart, which allows us to depict more than one. So depict 2 or more groups in a single bar chart. So we can have women and men. So what, sex of the U.S. workforce was this example. So in 1970, we had, substantially more men than women. And now more recently, we have more men than women, but the gap is closing. But we do also notice that we have more total people in the workforce. So this kind of tells us a couple different pieces of information. But at a glance, we're able to pull that information out of there. Hence, data visualization is important. Stacked bar chart. So group bar chart where the bars are stacked on top of each other so we can have some couple different pieces of information. Doing on time. Okay, I'm gonna just keep trucking. All right, pie chart, show relative frequencies for categories using a circle with each category, blah, blah, blah. We have a couple different kinds of these. We have exploded pie charts. So these are good for like highlighting one or two kind of significant pieces of it, where maybe, you might have 10 or 15 things you're showing, and maybe one or two of them are really stand out, and you want to explode those pieces out, as opposed to having everything exploded. So they could easily be misused because, somebody like me just thinks everything looks cool if it's exploded, right? So we might just do that. 3D pie charts, two-dimensional pie charts can be rendered useless if too many pieces, blah, blah, blah. So this allows us to kind of see things at an angle, or maybe it's easier to visualize the data. A lot of this stuff has to come down to which similar pie chart picture makes it easier to see the data. And then non-circular pie charts, I think the example in the book is like the Millennium Falcon or something like that, right? Which, maybe is, everybody knows what the Millennium Falcon is, right? Yeah, Camilla. Yeah, what kind of nerd are you? It's the Han Solo spaceship. Star Wars.
Oh.
Him and Chewbacca.
I want to talk to you about Chewbacca.
Do I do a Chewbacca?
No, but my brother does.
I can actually probably do a Chewbacca, but I'd have to practice a little bit.
And then you have to run. Pretty good.
All right. So non-circular pie charts, they might be creative, but maybe aren't necessarily that meaningful because you start losing size. All right, so now we have this thing called scatter plots. So it depicts the relationship between two variables on a rectangular coordinate system where each axis corresponds to one variable. These guys are for quantitative and categorical data. This is actually an interesting one. So if you're a college football fan, I'm not necessarily a college football fan, but I thought this was interesting. This particular scatter plot shows us on the y-axis, this is the rank of the team. On the x-axis, this is the salary of the coach. So down here on the far right, we see that, hey, these high paid coaches, these guys actually are, top ranked teams. This guy down here, I'm guessing this is like Alabama or something like that. He's making $7.2 million, but he's the number one ranked team, or two or three, really good. Now, this guy right here, this guy needs to be on Maddie's list of fired meteorologists. This guy right here, this guy's barely in the top 60. He's making, $5.5 million. You don't pay $5.5 million for a coach that barely breaks the top 60? Don't they only show the top 25 on ESPN?
Probably not even that.
And they only show the top 25. They only talk about the top 8.
Yeah.
Yeah. So this guy's no over here. This team, they're getting the deal. This is like top 10, and they're paying this guy. He's probably making 1.2 million. So chump change. He's making nothing.
These are head coaches. Do we know? Oh, it does say head coach.
Yeah, head coach total salary compared to their rank of their team. But this is just an interesting way of visualizing data.
Lower is better. Number one is best.
Correct. Yeah. Number one would be the best ranked team, and that also happens to be the highest paid coach.
No, so technically the zero close the y. So the higher the y is, the
worse. Yeah, I know.
Yeah. So they pay the less. More people pay very little.
This guy right here I'm circling.
This
is the highest paid coach and also the best team.
Rank 1 is the best.
Correct. He's the highest paid coach and he's the best team.
Yeah.
Yeah, correct.
Oh, wait.
I don't have the homework yet.
Think it faster.
All right, so you can read through the rest of these. This is just a, and I might start with it a little bit next class. But what I'll do is I'm going to give you a data set. I'll probably give you a link to download a data set. And I'm going to have you, based on the things you read in the first chapter and the code examples that are in there, I'm going to have you do some information, create some visualizations based on that data set. So you'll have to understand the code examples that are already in the book. There's plenty of them, and you can run those examples and things like that. So it'll be something similar to some of those, but then there will at least be one part of it that makes you connect some dots between 2 or 3 of those guys. And I'll have it up by, let's call it noon tomorrow. So I'll have to come up with a data set in the morning and that kind of stuff. But sound fair?
Yes, if I can't make my Python work, can I do Excel? Just kidding. I just kidding.
I was
have
getting
a-
errors when I was trying to import some of
That
it.
is maybe you have seen this error before.